finding the greatest common factor is useful in reducing fractions, but also has other applications. We're going to be looking at one of them in this lesson. Samantha is making a quilt and has cloth in two widths. One is 72 inches wide and the second piece is 90 inches wide. She wants to cut both pieces into strips of equal width that are as wide as possible using all the fabric. How wide should she cut the strips? This is an example of an application of finding greatest common factor. We're going to look at both numbers, 72 and 90, and I'll prime factor each one first. So let's look at 72 and then 90. We'll do our tree factoring. 72 could be 8 times 9. 8 can break down into 2 times 4. 9 breaks down into 3 times 3. 4 I can continue to break down into 2 times 2. And now I'll go to the roots of my tree and I will find that 72 is 2 cubed times 3 squared. So 1, 2, 3 factors of 2 and 2 factors of 3. So 2 cubed times 3 squared. 90, 9 times 10, 3 times 3, and we'll break 10 into 2 times 5. So I'll end up with, and I'll put them in natural order, 2 times 3 squared, because there's 2 factors of 3, times 5. So there is 90 prime factored. Remember that we're trying to find a number that will go into both 72 and 90, the largest number possible, which means what we're really finding is the greatest common factor. So when I look at my factors, I have in common a 2 and a 3. How many 2's do I have in common? Well, at most 1, because there's only one factor over here with the 90. So I have one factor of 2. How many factors of 3? I have a 3 squared here and a 3 squared here. So 3 squared will be a common factor that I have there. Now that means that 2 times 3 squared, or 2 times 9, or 18, is the greatest common factor of 72 and 90, which means that Samantha needs to cut her strips 18 inches wide. That means for the 72 width, she'll be able to get 4 strips, and for the 90-inch piece, she'll be able to get 5 strips. So finding the greatest common factor helped us determine what width the strips needed to be.